All right. Hello, everyone. I see more and more people are coming in. That's great. So yeah, welcome to this presentation of software tracing with SystemView. My name is Nino Vidovic. I'm one of SEGGER's embedded experts, and today we will learn a bit about software instrumentation and software tracing and how this can be done easily with SystemView. We will, after the talk, have a little Q&A session. So if you have any questions, feel free to use the chat here. Let me show you where it is. There, I think I posted now. This is the chat. So essentially, you can ask your questions there, and then at the end of the session, I will go through your questions and answer them one by one. So yeah, let's get started. Right, so the talk content, we will have a little introduction who we are, but we will keep this short and we will dive right into the topic of what software tracing is, what the benefits are, what you need to have and what you need to do to have a good quality of software tracing. And I will show you an example setup with a live demonstration I have prepared here. And then we will talk about the features that you get with this software, and we will have a little conclusion with the Q&A at the end. Now let's start with a little introduction. So who is SEGGER? Probably most of you are familiar with us, but who is not? We are a Germany-based company. We were founded in 1992, and we are now active for pretty long time and have production, engineering, and also support in Germany. So everything is made in Germany. And this way we always can offer our customers the highest quality in our products. And as you can see, we also have expanded globally to have coverage in different time zones with our FAEs. And our idea and our concept is that you have a one-stop solution from development to production when it comes to embedded targets, and you can get everything from one source and you get supported from one source. This is why we have these 4 pillars of our company, which is the embedded software, the debug probes, the software tools, and production tools. We're most popular for our debug probes. You probably have seen or heard about them, about the J-Link and J-Trace probes. Today's talk will be about our software tools, in this case SystemView, but we also have a big portfolio of embedded software and production tools as well. To give you a little overview of what kind of embedded software we also have an offer, you can see that we have an RTOS called MBOS, we used for many, many years now, and a lot of products. We have a file system, all kinds of connectivity stacks, which is great for IoT devices. We have an USB device and host solution, additional buses, and of course security features which become more and more important on embedded devices as well, and bootloaders and compression tools, so you can fit your software on any kind of memory, and of course our display library MWin, which is also available for many years now with a lot of experience and is available in many products these days. And of course, as I said, the software tools, for example, our ID Embedded Studio, Ozone, our universal debugger, which I presented on Tuesday with the J-Trace together. Today we will talk about SystemView. And yesterday was also a talk by my colleague Axel Wolf, who was talking about the App Wizard, which is our standalone solution to have an MWin set up on your host PC. So you click your GUI application together and then can see how it will look like before you put it on your target. So let's dive into the topic. What is software tracing at all? The simplest form of software tracing is your good and old printf. So essentially you print a string. At some point you say, okay, I made it up to here. Then you print again a string and say, I made it up to here. You have now essentially traced your software because you get an analysis feedback from your software that is running on your target device. Of course, this is a very basic approach of this. So we want to have more complex implementations of this and extract more information from our target device. The great thing about software tracing that you can utilize this in essentially any target application. So that depends on how complex you want it, of course, but you can always have this in your software. And but the biggest drawback is that you will, no matter how you solve this, have always a little impact on the real-time behavior of your application, because at some point you have to extract this data that you have collected to your host system, and your target CPU will be busy in some way doing that. On the left, you see a little picture. This should depict a little oscilloscope. I hope you can recognize it, but I like this comparison to an oscilloscope because this is essentially what software tracing, and in this case, SystemView would be. It is your oscilloscope, but in the end, your oscilloscope is only as good as also the probes you're using, and this was something that we'll talk about in the next slides. But let's talk first about some of the benefits you get with code instrumentation. So with just printf, you would essentially get very limited information, but with a more sophisticated approach here, you can have a more advanced debug and performance analysis features, because you can track essentially where time is spent in your application, how the load balancing is, how the application is running at all. Are the, for example, if you're using an RTOS, are the task switches and events triggering as expected? Are you spending somewhere too much time, etc., etc. So it helps not only with debug, but also with testing your hardware and application, of course. And the greatest benefit is no additional trace hardware is required. As I said, on Tuesday, I talked about hardware tracing. And with hardware tracing, you always need some kind of additional extraction pins on your hardware that you have essentially to sacrifice. You, of course, get another quality of tracing there. But the drawback is always you have to use additional pins. This is not necessary for software tracing in this solution that I will present you today. So yeah, let's get back to this comparison to the oscilloscope. So as I said initially, an oscilloscope is only as good as the probes that you're using to measure inside of your, in this comparison, the hardware setup. And if you use a very cheap probe setup, you will have a lot of noise. You will have a high impact on your hardware. This is something you want to avoid, and your measurement setup should always be as low impact as possible. And at the same time, you want to have a very high resolution so you can pick up even the smallest changes in your system. And the probe equivalent in this metaphor is the I/O interface that you're using to extract the data from your target device to your host PC for further analysis. And this is something we will talk about now. So as I said, the standard solution for such I/O implementations, or the most used I/O output is printf, or I/O function is printf, which is short for print formatted. So essentially you have a string, a formatted string. It gets output over some type of I/O interface, and you have it on your debug terminal on your host system. It's probably the most widely used debug and standard output function in all programming languages. And on embedded targets, the I/O channels that are usually picked is UART, semi-hosting, or SWO. But all these three solutions have one big problem in common. It's usually a pretty high overhead, and the time that your application is spending exporting this data to the host system is wasted, and this is something that you want to minimize, especially on an embedded target where you have limited resources and speed. And luckily, we at SEGGER have a solution for this. We call it real-time transfer, RTT. On the left, you see a little graphic that shows what it essentially is. It's two or more buffers, one up, one down buffer, or more. The great thing is it's an I/O channel, so it's not only an output channel from the target set, but you can send data inside of your running system as well. It has really minimum impact. I will show in the next slides how low it really is. It can be used for free if you have a J-Link. It works on essentially all target devices that are supported by J-Link and supports some kind of background memory access where we can extract the data while the target is running. And as I said, the greatest thing about this, no additional pins are required, as we are using here simply the debug signals, SWD or JTAG. So you don't have to change your hardware design. You simply add the SystemView software to your application, and that's all you have to do, and you get a very deep insight in your system. So let's dive a bit deeper in the technical background. So I said there are up and down buffers, which you put in RAM. We have different operating modes depending on how you want the data to be collected and what happens if one of these buffers overflow. The memory footprint is extremely low, so it will not be a major impact on your whole target application size. And the transfer speeds are also very high. So here's an example setup where it's about 2,200 kilobytes per second. So you can also extract a lot of data there if needed. And on the bottom, you see a little graphic, which you can also find on our website, which compares all these different IO types with similar setups. And here we had measured the time that the target application wastes to output 82 characters. And if you use RTT, it's about 1 microsecond. If you use one of the other implementations I showed, you see that they're in a completely different league and much, much slower. And this is simply time that is wasted in your application to simply output data to your host system, and the application is not doing its actual task. And this is something you try to avoid. UART is missing on this slide, but UART is usually somewhere in between a WEO and semi-hosting, so somewhere around here, just for clarification. So yeah, that's what system or what software tracing essentially is. And I would like to switch now to my live demonstration setup, where I will use SystemView and Emboss application, which is always instrumented by default. So you can simply download. If you use Emboss, you just download SystemView, run it, and it will simply work. And the IO implementation will be RTT as talked before. So let me just switch to my demonstration. So here we go. I think you should all see now SystemView. The first time you open up SystemView, you will be greeted with this example recording you see here. So recordings can always be stored and loaded at a later time. This is one of these recordings where we have some web server application running on an embedded target, which is where it is the MK66 from NXP. And so yeah, let's explain a little bit what you see in this different windows. So up here we have our complete event list of all the all the extracted data from the target device with all its contexts, events, and details. We also have a context window, which shows things like the stack information of our tasks, how often what has been activated, what the running time, block time is, what the CPU load is of the different functions, and much, much more statistics. So you see it's a very sophisticated and deep analysis of your system. You, of course, have your printf terminal. So if you have to have some kind of log, you can also print it out here in your different tasks, for example. And the nice thing is all these windows are interlocked. So if I select this print, you see it here in the event log. And again, here in the timeline, this timeline essentially is timely or graphic representation of this window on the top left. So you can zoom out here, go between tasks, measure and display exactly how long what task execution has taken, how long the scheduler took to switch between tasks, and all this nice information. At the bottom, we also have a graphic that follows this timeline and shows essentially the CPU load of the current point in time. And you see at which time, which task or interrupt or whatever is spending the CPU cycles. On the bottom right, you see the Systems tab, which will give detailed information about the recorded sample here or the record setup. So what the target device is, what application was running, how many recorded events are there, what the frequency are, did you get any overflows, what the analysis duration is, etc., etc. So let's get to the point of the live demonstration. So I've prepared here a Cortex-M target based on an STM32 F4 target device, and it's running also an emboss target, but just with two tasks which are blinking some LEDs, and I have a JTrace connected here to the target device. So I just click here on Start Recording, and here we go. We're already running, we're recording in real time now. So you can track how your application behaves in real time. You see the sysdig here, for example, and some task switches happening, but we can also stop the recording. So we can analyze this in a more calm fashion. And here again, we see all the recorded information we've just recorded here. We see the two tasks that have executed, one high priority, one low priority task. The scheduler and the sysdig is running. And essentially, the sysdig is millisecond sysdig. So this is what you can also see. You see here at 0. So you see it repeats approximately every millisecond. And if we go to the low priority task, for example, we see a task switch that gets activated by a sysdig when the task is ready. And we can see it took 12.6 microseconds, for example, for this task to execute. Or we can go to the high priority task. Here's one which took longer because it called some more functions. And yeah, this is how we can get a detailed runtime information from our system without having expensive hardware tracing setup, but just simply instrumenting your own application and extracting this data with SystemView and the JLink. So let's go back to the presentation. So yeah, this was my live demonstration, and let's summarize what features we have seen. So SystemView offers 3 different recording modes. It's continuous recording, single shot recording, and postmortem. Continuous recording is what I showed you right now. So essentially just hook into your running system and get all this information streamed out. Single shot recording would be that you set the RTT buffer to fill up once when you specify a specific starting point, and then just have a specific part of your application captured. And the postmortem mode would even work without the JLink. So if your target, for example, crashes or something, then you could attach with a JLink and extract the last SystemView data that was selected and try to analyze crashes this way as well. As you see, you can capture all kinds of deep information about systems, tasks, switches, interrupts, timers, even API calls if you use different embedded software. But even applications that do not use an RTOS can also be instrumented and used. So if you have a super loop application, SystemView can as well be used and be very useful. The main supported I/O interfaces are RTT, UART, and IP. We obviously recommend to use RTT because of the advantages that I mentioned, but you can also use your UART or even over Ethernet. So your host PC receives this over your network, and that in that way you wouldn't even need a debug probe to extract this data. We support essentially any RTOS. So as I said, any application can be instrumented with SystemView, so any RTOS can be instrumented with SystemView. Emboss is instrumented out of the box, so you simply, if you have an Emboss running, all you have to do is download SystemView, press on record, and you will already have SystemView running. For the other RTOSes, we ship patch files for the RTOS kernels, so you can patch them yourself and have instrumentation up and running in a little time. It's free to use if you're a non-commercial user, so you can, and for evaluation, so if we just want to test the software out first, no problem, just download it and test it out. And we offer multi-platform support, so it doesn't matter what developer PC, what your developer PC is running. If it's Windows, Linux, macOS, we don't care. You can use SystemView there. So let's come to pricing. This is especially in context of the embedded world, usually interesting. So SystemView, SystemView single user license costs 798 euros. The different license models we have is a single user license. Either it is you're locked to your J-Link or JTrace probe, and then they function as a USB license dongle. So wherever you take your J-Link with you, you will have your license in the pocket and can use it directly on your desk. You can also have a PC locked version, and we have multi-user license inside and company-wide license models. So yeah, let's come to my conclusion. The live demonstration part I've shown already. As you saw, it's a very powerful tool. It's pretty easy to set up. It's extremely easy to set up if you have Emboss, because you just have to start recording, and it gives you very, very deep insight in your running application. You can do great analysis with this. And if you use RTT for the extraction of the I/O data, the real-time impact is minimal, so it is suitable for essentially any embedded setup. So yes, that would be my talk. Thank you for your attention. I hope you guys learned something today, and I hope to see much more SystemView users in future. Thank you. Right, let me see what the chat has to offer. It's not opening up for some reason. Let me just stop screen sharing for a second. Okay, now I have this chat. Where are we? All right, first question was, do I need an implemented RTOS to use the SystemView? No, you can essentially, oh yeah, Gizem answered this. This is one of my colleagues. Thank you, Gizem. So yeah, and also no OS applications can be instrumented without any issues. So feel free to give this a try. On our SEGGER wiki, we have a guide for this. So essentially, you should be able to get everything up and running with just the SystemView manual. But for additional assistance, we have our wiki page, wiki.segger.com, and there you can find more detailed step-by-step instructions with example applications for RTOS applications, for non-RTOS applications in different fashions. So you can tune this a bit to fit your needs, how this should look like, what is our output by SystemView, etc. Do I need to edit heap to use SystemView is another question. No, you don't have to edit your heap specifically. You just add SystemView to your to your existing application, and it will just fit in nicely. So there are no specific requirements. Of course, you need a bit of RAM that is used for these up and down, or in this case, or specifically the up buffer. But there's no need to change your heap or stack or anything. Is it Kyle RTOS instead? Yes, as I said, you can instrument any RTOS. So Kyle RTOS is also instrumentable. For KaiArtos themselves, we do not have a patch file, so you would have to do the instrumentation yourself. But usually, the system view hook functions that you put into the kernel of the RTOS are single line. So it's just a system view API call where you, I can show this a little maybe. Let me go back to my slides. 1 second, please. Share the screen. So yeah, here we go. So here are some example code snippets, how an instrumentation would look like if you put it into your RTOS sources. So this is taken from Emboss, for example. So in the Emboss create task function, we essentially have to grab all the informations from this task that is currently being created and put it into a struct that is used by SystemView. And we essentially just copy the information that the RTOS already has, and then we do the single line call of SEGGER SystemView send task info and give SystemView this information via the RTT buffer. In all other cases, the instrumentation is literally just a single liner, essentially, where you just use the call. For example, if you have an interrupt enter, you just call record enter interrupt. If you exit an interrupt, you call exit interrupt. If you enter a user function, you call enter user function, etc. So it's very straightforward and easy to use. Yeah. Let me see if I can. Yes. All right. So are there any more questions to this topic? You can always also, if you don't want to use chat for this question, you can, of course, always send me a message on the Embedded Word platform. I will gladly answer them. And yeah, as Gisem wrote, all important information can be found on our website. Yes, you can find how to do the patching, etc. also in the SystemView documentation. So the question was, is there a how-to for this? Yes, you can just check out the documentation that gets shipped that you can find in the SystemView installation folder. There will be a PDF there, and you can simply use that as a reference. All right.